Hello dear students, welcome to the second lecture. In this lecture and also in the next week, we will learn about some tools that we will need to analyze electronic circuits. The first tool is the IV characteristics or the current voltage characteristics. Suppose you have made a new device which has two terminals. Now, if I ask you, what are the properties of this device? How would you describe it? How would you describe the properties of an electrical device? Well, an electrical engineer would characterize its properties using the relationship with the current and voltage. That is the IV or current voltage relation, which is also known as the current voltage characteristics. This is the relationship between the current and the voltage. That is the voltage as a function of current or the current as a function of the voltage. When we know this relation, that for example, for every possible voltage, if we know the current of this device, say for every possible voltage, we know the corresponding current entering the device, then we have enough information to analyze a circuit. Say we have a complex circuit where we have placed this device. Say it's a part of a big circuit. There might be some resistance, there might be some voltage source here. It's a part of a big circuit. And in that circuit, we have placed this device for which we have this relation, the current as a function of voltage. Then it is enough information to analyze this circuit. That's why when we are dealing with circuits, we characterize a device by the relationship of the current and the voltage. Now, how can we find this IV relation? Say I gave you a device and I asked you to go find the IV characteristics of this device. Well, an easy way to do this would be, say I have this device and I want to find the IV relation. So what we can do is we place a battery, say positive here, negative here. We place a battery we connect a battery with this device and we vary the voltage of this battery. And for every voltage, we measure the corresponding current and we tabulate the data. Say for every voltage, we measure the corresponding current. Then what we will end up is the IV characteristics of this device, because for every possible voltage, we know the corresponding current. For example, say when the voltage is 0, the current could be 0. When the voltage is 2, the current could be 4. When the voltage is 6, the current could be, say, 12, and so on. So this is one way to represent the IV characteristics of a device. Another way is to represent it using some sort of function. And a third way to represent the IV relation is using a graph. So what we can do is we set up our axis, and in the x-axis we plot the voltage, and in the y-axis we plot the current. And say for example, for this voltage we get this current, for this voltage we get this current, and we plot all the points that we get. After getting all the points, then what we do is we connect all the dots, and what we end up with is a graph. and this graph is called the IV curve of this device. Note that this table and this graph, they both contain the exact same information. This is just in a tabular form and this is in a graphical form. So this is the IV relation of a device, how the voltage or how the current changes with the voltage. Note that when we are calculating the IV relation using this method, the voltage here is working as an input. We are using the voltage as an input and we are measuring the output current, right? We are measuring the input voltage and we are providing an input voltage and we are measuring the output current. So the IV relation or the IV characteristics is also known as the input output relation of a device. So to recap, the IV characteristics or the IV relationship of a device is nothing but the relationship between the voltage and the current of an electrical device. We can represent this IV relationship using a function or using a table. How can we find this table? We connect a battery with this device and we vary its voltage. And for every possible voltage, we measure the corresponding current. And this would give us the IV relation of this device. A nice way to represent this relation is using a graph where in the x-axis we plot the voltage and in the y-axis we plot the current. This is known as the IV curve. That is for every possible V and for every possible I, we connect the points and the curve we get is known as the IV curve of this relationship. In the next video, we will see the IV curve or IV relation for some common electrical devices that you are already familiar with. Thank you.